The recording is started. Lecture is on for the day. Okay, so last time I made a point just before we ended, but I'm not sure if many people were awake at that point, so let me repeat that point. So that was, if you have anything to the power half, it's the same as that same thing square root. Right? That's the point we made. And we can even take it further at this point. Okay, but let me not jump ahead because we're going to get to the generalized rule in a moment. So generally, because we can represent square roots of any root as a power, it means we can use exponential rules to simplify these things. So in a way, you don't have to worry about all of these rules if you consider them as powers. Consider square roots as powers, then we've gone over the stuff already, right? But maybe it's good revision to look at it again. So, okay, all this is saying is if you have something like, this is kind of going the other way from the way we went originally. If you have something like, let's see, square root A times B, it's the same as square root A times square root B. We can break the square roots up, is all it's saying. And if you think about the square roots as powers, you will see that this is quite obvious from what we've done before. I mean, let's just look at it. If you think about this as AB to the power half, we know the half distributes to both terms. Right? Same thing. What I wrote at the bottom and the top are exactly the same. So if you're comfortable with powers, then you can use the powers and then just convert in your mind to roots, because then you don't have to learn something new here. It's the same as what we've done already. Okay, let's see if we can look at examples. All right. Let's start the morning with some examples. Do you guys want me to do the first one? Yes. Okay, I'll do the first one. You can try the second. So the first one simplifies to, again, think about the square root as a power, so it distributes to all the terms. This becomes square root 9, square root x to the 6, square root y4. Simple as that. I think we can simplify things a little bit further here. We can rewrite the square root 9 as 3, right? Square root of x to the power 6. Let's think about that. If the square root is just a power half, then I can rewrite this as x to the 6 raised to the power half, and maybe that will help us a little bit. And the last bracket, same story. I can rewrite this as y4 all to the power half. It's early in the morning, but if I lose anyone here, just let me know. You guys might have seen this. Do you guys see this in metric? You do? Okay. All right. So that's good. So now I can simplify this further. You guys remember that if you have a power in a bracket and then you're raising it to another power, you need to multiply those together. So that, let me not put a bracket anymore. We can undo that bracket and write this as x to the 6 times half. And this side it becomes y to the 4 times half. In other words, that is just x to the 6 over 2, which is just 3, y to the 4 over 2, which is just 2. Is this straightforward enough for you guys? Okay, let me give you guys 30 seconds to try example 2.
Hey, that's crazy. That's crazy. Oh, shit. Oh, so look at these conditions.
Sorry, but the book you read,
Also again.
sorry, that's
Yeah, it's gonna smell like mold again. That's let's move together.
yeah, you can.
It's Friday.
don't worry, you got a lot of witnesses there, so we'll try and get PC to pay for that.
University.
That's crazy, man. You guys are paying so much fees and the roof is leaking on you.
Yeah,
Probably the economy. That's going to be another problem.
No, it's like next. I think last week, I think it like the over there.
This, oh,
You see the lock and then like you pass everything goes more.
what, like not by the aircon, just by the roof.
Yeah.
Yeah, you probably right. Okay, so guys, during the halfway break, I'll try and ask someone to come and look at that. I'm not sure they will anyway. Okay, guys, everyone else around there, okay, you guys didn't get wet? You guys want to move just to be safe? Or you okay?
What's the one? What's the next? Yes. That's bad.
Okay, it's so hard to focus on work when shit like this happens.
Yeah. Still going on recording.
Yeah. Okay, so guys, you might notice when you see something like this, and if you get comfortable enough, you can do this in one step. You don't have to worry about incrementing it. So I'm going to just do that for you guys. If anyone is confused, let me know. 49 squared, we can write, sorry, square root of 49, we can write as 7. X to the power 10 raised to the power half is basically taking that 10 and halving it. Right, so that's just x to the 5. And the same story with the 8 here. Okay, if you need to do it the long way to check, please do that so you get comfortable with it. Okay. Okay, now what's happening here? Okay, guys, now we're getting some strange stuff here. This is where usually people make mistakes, so we have to just be careful with this. And maybe I should make a general rule before we go ahead, because these nodes always like increment us slowly to each thing. We should just one time look at the general rule. So this is one step of the rule here. It says if you have the square root of x squared, let me show you guys the common confusion first, right? Usually, if I had something like square root x squared, what I would think to do is write this as x squared to the power half. X2 over 2 just becomes x to the 1 of x, right? That's what I would usually think to do. But this is telling us when you have something which is a power and the same root is taken, right? So the square root and a power 2 are happening together. Then the answer to something like this is the absolute value of x, not just x, right? Anyone seen that before? Okay, so we have to remember this rule, right? The general rule would be if you take the nth root of x to the power n, this is the absolute value of x.
Between just x and the absolute value of x.
Okay, that's
What is the difference between x and the absolute value of x?
The absolute value of x means that whatever x is, even if it's negative, the output will be positive. But x alone, that you can have negatives.
Yeah.
Okay, so I guess if you try and look logically at the reason why this happens, it's because here the x could be negative, but the square will get rid of that negative. Then once you square root that, you get a positive output. Right? So that's why the absolute value here will always give you a positive output. Okay. But again, if you're not worried about that stuff, it's okay. Yes. If it's in this form, then yes. Only this n and this n are the same number. If it's different, then we will do what we did in this previous example here. We just simplify like normal powers. Okay. So slight distinction here. Let me just go back to the general rule. Okay, so guys, try to use the general rule and simplify this up here. I'll give you like another 30 seconds to try that one. Last time I said that the roof started leaking, so let's hope it doesn't. Yeah, guys, I wouldn't trust the water. If it's rainwater, it's probably going on the roof with all the bird trap and stuff, and then that's how you start a new COVID pandemic. Okay, guys, so this one right here, we will simplify to a cubed b5 c squared. I break it up so we can see the one which simplifies using the rule we just learned. That's the last one right here. Everything before that simplifies according to how we did the first example. So this first one is going to be a to the 3 over 2, b to the 5 over 2, and here we got c. Yes. If they ask you to simplify things, to me, what you did was more simple than what I did, right? This looks like you're complicating things more. So, I would mark this. No, you were just learning a rule. It doesn't necessarily mean this is the most simple form. So I always emphasize, maybe I should announce this, guys. I always emphasize this when they say simplify something. Simplify is quite a relative term, right? To some people, this looks more simple. Some people leaving a square root here is more simple. So I'm always lenient with things like this. If they say simplify, write it how you prefer. It's just that this needs to be shown, right? That's the main thing here. And the reason we're doing all this nonsense is just to show you the rules of the section. Because to me, this looks like a mess. I don't really like it. Unless it's like 4 over 2 or something, then it's okay. Okay, cube roots. Why is this a thing? I don't know. Why is it a thing? Okay, maybe I should mention one thing about cube roots is that you guys know with square roots, you can't have negative numbers, right? You can't take the square root of a negative number. Maybe I shouldn't assume that we know that. So let me mention, if you have something like square root of -1, we usually don't deal with things like that, right? Because, okay, let me put a number that we can digest. Let's say, if I said square root of 4, you guys know the answer to that, right? It's 2, right? But if I said square root -4, try to think logically about what answer would work for this. In other words, what number? Let's see here. We know if I square this, I get back to 4. That's why it works. What number can I square to get back to -4? Nothing, right? You try and think about it, there's nothing that works. So we just look at that and we say we don't like it, so just ignore it. Yeah. But now with a cube root, you can have negative numbers because you can cube something and get a negative result. So that's the only thing to look out for with cube roots. Like the cube root of 8, we know is 2. The cube root of -8 is -2, right? So we can have those in cube roots. Okay, I don't know what else to say about cube roots. Anyone has any questions about it? The only thing to note is we can now have negative numbers. And let me ask you guys, if I had a 4th root, can I have negative numbers in that? No. If I had a 5th root? Yeah. Yes. Okay, so you guys get the pattern. Right, it's every second, every even number, every odd number, sorry. Every odd root, yeah. Every odd root you can have a negative number. So that's that. Let me try not to waste too much time with these examples. Okay, I'm not going to waste too much time with this. I'm just going to do this one for you guys to see, right? It's similar to what we've been doing already. If you're going to try to beat me and do it before me, you can do that. I'm going to do this quickly. This can be broken up into the cube root of 32, cube root of m to the 5. which is the same as, anyone knows the cube root of 32? Sure, it must be a number. Why we gave it? Is it 4? Is it a thing? There's nothing. Okay, if there's nothing, we can just leave it like that. Cube root of 32. Can someone just check in the calculator though? I mean, I don't want decimals. If it's a nice number. Decimals. Okay, then let's just ignore it. We'll leave it like that. And there's cube root m to the 5. Can you guys tell me what that becomes? Perfect. M5 over 3. But if you start getting confused whether to put the 5 on top or the 3 on top, just go back to the rule and double check. Initially, it can be confusing. Do a few examples and you'll get the hang of it. Okay. Do you guys want me to do any more examples with these? Anybody? You guys already beating me to the next one. Okay. Awkward silence it is. Okay, anyone wants to see one more? One more, okay. All right, so let's do this one at the bottom. Cube root of negative 27. You guys just want to see me struggle with ordinary numbers. That's what's happening. Cube root negative 27. Cube root of x to the 4. Cube root. Okay, I guess I see why they're giving us this example. Okay, so cube root of negative 27 is 3, minus 3, sorry, minus 3. Thank you. The negative sign is important there. So this simplifies to minus 3. This simplifies to x. You guys tell me this one. What's on top, 3 or 4? 4. 4 over 3. Yeah, that's right. And this last one here, do I need to put an absolute value for this one? Yes. A good question. I wouldn't think so because it's not an even number, right? It's not an even number, so no. So this just becomes y. Yeah. Because this is not an even number, so this only works if the n and n are even. Yeah. Okay. So I think we mentioned that, but we didn't write it with the general rule. So maybe we should note it. Is it here? Okay. Oh, it is here. The general rule comes up here. N is even. Okay. Thank you for being ahead of me. Okay.
Why do we have 4 over 3 and not 3 over 5?
Because it's a root of 3, so the 3 comes with a 1 over 3. So yeah, so if this becomes confusing, this is always nicer to just write as x to the 4 to the power 1 over 3. Then you can see it becomes 4 to 3 times 1/3. I mean, sorry, 4 times 1/3. Yeah, which is just 4 over 3. Okay. Okay, any questions before I move on to something else? So here's a summary of the rules we just learned. Yeah, this is exactly what we use. We saw both situations, the one where the n is odd, one where the n is even. We've dealt with those. Okay, and for some reason, they just keep on throwing examples at us, which is a good thing. You guys can try more at home, more practice, but fortunately, our time here is finite, so I have to move on. Let's see what these questions are asking us for. Okay. Okay, this is just to get comfortable with the words as well that we just learned. So let me give you guys, I don't know, 20 seconds per example. Let's see if we can try them.
I see the water came from the aircon from this big.
It's right next to the aircon, so it's basically a.
When you guys do that, I get worried because I make mistakes often. That I, it's okay. Okay. Oh, nonsense. It's nonsense. So yes.
I think the plot really one is something. So you can simplify that as a number. If you can get it to a number, then just try to.
So it's supposed to be illustrated.
But you don't need to like, I think you simplify such a deletion. I believe because thing with each of the calls for all those you can
Okay, guys, anyone got anything different than what I have? For the last one, again, I gave you options because simplify is a relative term. First one on top or the one at the bottom. To me, the one at the bottom looks more simple, but again, whatever you prefer. Yes. Yep.
Would it be ridiculous if you're gonna let you two of the and then the X.
Yeah, I was thinking about that. 2 to the power half, though, is square root of 2, so that's a different number. Something to the power half. 4 squared to the power half is what. I mean, you could do that, but it's not necessary. My brain didn't work out. 4 squared is what, 64. 64 to the half, if you wanted to, but
Yeah, that's ridiculous.
Yeah, see, if they ask stupid questions, they get stupid answers. Right? Anyway, I shouldn't be saying all this on video. How many more do we have? Okay, let's just try two of these out of all the examples. Try the rest at home. Let's try these two. So if you guys ever see these disclaimers here at the bottom, just don't worry about it. It's just telling you something which doesn't affect the way that you do the example. Hey guys, if you're busy, keep working. Don't worry about me. I'm just going to start the first one on the board. If you want to see, you can watch what I'm doing. Hey guys, I'm going to do this in more than one method. For some people, this might be a bit too much, so I'm going to try and not complicate it this much. A quicker method, but if you guys get confused, don't worry about the quicker method. The more steps you show in the earlier days of learning the stuff, the easier it will be for you. But I'm going to try and show fewer steps for those who want to see that. No. Question.
When you, for example, don't get cancelled.
That's one cancel is fine. It would if that was next to the power to the side. So
Oh,
then you take a cube root and you're cubing, so under is one another. It's
Coffee wasn't in there. Yes, but it's not in. It's very big.
yeah. Only this interview. It's yeah. Track the why. Yeah. Yeah, you got 9. Why did I get 6?
Sure.
Possible evidence.
It's really my mom's in Well, I never had one.
I got it before, but you got a song. It's a thing. Something. Yeah. Yeah, so that's fine. It's multiplied though. Yeah.
He dropped that.
So that's the only mistake you're making.
Yes.
Yeah, so the way you wrote it is fine. Again, that simplifies the thing. Yeah, it should be true.
Okay, guys, everyone okay with the answer here? Anyone wants to see the second one? Yes, okay, let's do the second one. All right. Quarter of 16 is 2. Yeah, okay. All right, so okay, let's just go for it. 2 to the I'm going to do it the other way here. Just put everything together. 16x9 equals x. Let me take out this. Okay, if I'm doing this, I might as well just take all the numbers out. So let me not do half things. Let's just do that one time. Take all the numbers out to the front. So 2, 4th root 16, and the 4th root 81. I'll keep all the variables in another one. Make that better. Okay, so we're left with the 4th root of x to the 9 cubed. Okay, I don't want to move too far ahead if I'm losing anybody. Do you guys all see what I did here? Okay, right? Just pull the numbers out. So, right, guys, correct me if I'm wrong here. The 4th root of 16 is 2, right? 2, and the other one should be 3. Okay. Then we good. Absolute. For which one?
Yeah, maybe express it.
So only for variables we do that.
Oh, okay.
For actual numbers, it doesn't matter. Okay, so guys, that's a good point. Absolute values and stuff don't matter for actual numbers. We only apply that for variables.
Oh,
Right? Okay. What an odd thing. Yeah. Okay, so anyway, where was I? Simplifying this one to x to the 9 over 4, y 3 over 4, y 3 over 4. Actually, sorry. Let's just simplify them inside the root first before we do anything else. So what if I just say this? X to the 3, 4, 5, 9, 12, and 4.
Yeah.
That makes our lives a bit easier. So here we get 2, 4, 4, 12 on this side. Here we get x to the power 12 over 4, y to the power 4 over 4, which is 12, 4, 8, 12. So x cubed, y. Okay.
Yeah.
So in that case, we should apply.
Yes, you're right. You're right. Sorry, guys. Absolute y, right? Absolute y because the powers are the same and they are even. Yeah. Okay. So that one catches me all the time as well. So you guys just look out for that as well. I always miss it, but I'm not writing exams, so you guys need to be careful for it. Okay. Because the rule is that if you take the root of something to the same power and it's even, then you put an absolute value. Yeah. Okay. Give me examples. Okay, guys, you need a break. Okay, 15 minutes. Stop the recording.